All right, so we're back again, and today we're working on pages 14 through 16 in your packet. Now, page 14, there's nothing new on this page, okay? I'm going to go through everything very quickly, but these are the first three definitions we learned about, okay? Amplitude is the height from the midline. Frequency is the number of complete cycles between 0 and 2 pi, or in a span of 2 pi units. And the period is how long it takes to complete one cycle, or the horizontal length of one complete cycle. Okay, so those are our definitions. Now these formulas, all right, we're going to use them a lot today. This one we haven't used so much, but if you look through, frequency is 2 pi over period, and period is 2 pi over frequency. Your vertical shift, this actually is a new one, we haven't used this, is equal to the max minus the amp. So you'll see we're going to use that today. Your max and min, we did use these formulas in the last video. Okay, the max is the vertical shift plus the amplitude, and the minimum is the same thing, but we're subtracting the amplitude instead. And then this right here tells us the setup of any sine or cosine curve. All right, so we're going to flip to the next page and see how we're going to be using all of this information. Okay, so if we take a look at number 25, which is on page 15, it says the following function can be modeled by this equation right here. And what they want us to do is they want us to determine the values of A, B, and C and justify how we arrived at our values. Okay, so I'm first just going to talk about what everything means in this equation. Now, we know the number in front of the word sine is our amplitude. So let's just label everything. So this A is going to be the amplitude. Okay, we know that the value in front of the x, or after the sine or cosine, is our frequency. So this B right here is going to represent the frequency. Now, if we had a number being added or subtracted within the parentheses from this x, that would be our horizontal shift. But since we don't have that, we don't have a horizontal shift here. Okay, this graph is not being shifted horizontally. But if we have a number added to the end of our function, or being subtracted to the end of the function, this right here is going to represent the vertical shift. Okay, it's going to tell us how far we're going to move our graph up or down. All right, now we could probably figure all of these things, based on this graph. We could probably figure them out based on sight. But I like to use the formulas because it makes it nice and easy to just consistently get a correct answer. Okay, so these are our formulas, the ones that we're going to need from the previous page. I know there was a lot more on that previous page. All right, so the first thing we have to find is the amplitude. So I'm going to use this formula right here. Amplitude equals, let's write it down. The more you write something, the easier it is to remember, right? So the amplitude is equal to the maximum minus the minimum over 2. All right, so let's look at our graph. Well, the max height, see this right now, this is the highest point. The max height that it reaches is a height of 2. So the maximum is 2. Okay, and then minus, well, the minimum, this is the lowest point the graph reaches, and that has a y value of 0. So the minimum is going to be 0. And we always just divide it by 2. So then 2 minus 0 is 2. And then 2 divided by 2 simplifies to 1. Okay, so when they want us to determine the values of A, B, and C, we just found A. We found the amplitude. All right, so let's make an answer key box, right? It's always good to box off your final answers. So here's A, B, and C. So A, the amplitude, we just said is equal to 1. Now let's just think about what the definition of amplitude is. Definition of amplitude is the height from the midline. Now let's think about this graph, okay? Let me make a dotted line here. This right here, this dotted line, would be our midline. This would be the middle height of our graph, right? Doesn't it cut it right in half, the height? So here, the height from the midline, well, to get from the midline up to the maximum, aren't we going from a y value of 1 to a y value of 2? So we're going 1 unit up. Even though it's 2 boxes, to get from 1 to 2 is still 1 unit. So here, if you're looking off site, the amplitude would be 1. So you could do that off site if you prefer, instead of using the formula. But when it does say justify, if you don't use the formula, you could just say amplitude equals 1, and you could put, because it is the height from the midline. Okay, you could explain in words if you want. All right, now B is the frequency. I'm just gonna use the formulas because the formulas, that's justifying my answer. I don't have to put any words down. I'm just, showing how I got the answer. So I'm gonna use this formula right here. So the frequency is equal to 2 pi over the period. Now, if we want to use this formula, we have to remember what the period means. All right, the period is how long it takes to complete one cycle. Okay, it's the horizontal length of one complete cycle. Now, isn't this one complete sine curve? And if we look down, it takes us 4 pi units to get there. So the period is 4 pi. All right, so this is going to be 2 pi over, and we just said the period is 4 pi. So what we have to do is simplify this. All right, well, the pi on top will cancel with the pi on the bottom, and 2 over 4 simplifies to 1/2. So the frequency is 1/2. And if you want to think about what frequency means, frequency is the number of complete cycles between 0 and 2 pi. Isn't this just half of a sine cycle between 0 and 2 pi? So that's why the frequency is 1/2. Okay, and then finally we have to find the vertical shift. Now, I'm going to use the formula for vertical shift, but again, we'll talk about how you can just find it based on sight, based on looking at the graph. So here we see the vertical shift. This formula we haven't used is equal to the max minus the amp. All right, so the vertical shift is the max minus the amp. Now, the maximum height that this graph reaches, we already said, is at a y value of 2. So I'm going to replace the word max with a 2. And then minus, well, we found the amplitude right here to be 1. And then 2 minus 1 is 1. So C, our vertical shift, is equal to 1. And let me just talk about why. The vertical shift is, how far we had to shift up or down to start our graph. Or really, the vertical shift is really just equal to wherever your midline is. See that? The midline is where your vertical shift occurs. So the vertical shift is right here at +1. Okay, now 26. Now, if we look at this setup here, okay, we have something in addition to what we had in 25. We also have a horizontal shift, right? If we have a number being added or subtracted within the parentheses with the x, we also have a horizontal shift. So here we have A. I'm just going to label everything again, okay? So A is our amplitude. B is our frequency. C is the horizontal shift. And then D is our vertical shift. Okay, so it looks like amplitude, we have a formula for. Frequency, we have a formula for. Vertical shift, we have a formula for. Horizontal shift, we don't, but we'll talk about how we're going to find that. Okay, so I'm going to do the same thing we did for 25. You may want to hit pause and see how you do. Use your formulas, or at least use your formulas for amplitude, frequency, and vertical shift, and see how you do. Okay, so I wrote out the formulas here, and, it's really very similar to number 25, okay? So for amplitude, max is, again, 2. Minus min, the min is again at a height of 0, so we have 2 minus 0 over 2. So again, 2 over 2 simplifies to 1. So our A equals 1. Okay, now let's find the B. So the frequency is equal to 2 pi over the period. So again, the period is how long it takes horizontally to complete one cycle. Now here's the deal. This is a cosine curve. Now, a cosine curve starts high, but doesn't it also end off high? So if we did want to finish this curve up, I'm just going to make it like dotted line, I guess. I guess it would end right about here. Now let's think about this. This is 1 pi, 2 pi, 3 pi, 4 pi. So wouldn't that be 5 pi? So if this is the starting point of a cosine curve, and this is the ending point of a cosine curve, okay? Our cosine curve, I'm just going to go like this. So the period, oh, hold on one sec, my phone's ringing. Okay, I'm back. I forget where I was. Oh, we were talking about the period. Okay, so the period is how long it takes to complete one cycle. So since this is the beginning of the cosine cycle and this is the end of the cosine cycle, it takes, let's say, to go from pi to 2 pi would be pi units, another pi unit, another pi units, and another pi unit. So it takes 1, 2, 3, 4 pi units. Or you could say 5 pi minus 1 pi is 4 pi. So the period is 4 pi. All right, so this is going to be 2 pi over 4 pi, which the pi's cancel, and that leaves us with 1/2. Okay, so we still have to find C and D. So now C represents the horizontal shift. So normally, cosine starts, when x is 0, cosine starts at its high point and comes down and then comes back up. But here, instead of starting at 0 along the x-axis, it was shifted over. Here, let me draw a dotted line. It was shifted over. Oh, that's a really bad line. But it was shifted over here at pi. Pi is when we start a cosine curve, right? A cosine curve starts high and ends high. So pi units to the right is going to be our horizontal shift. Okay, so C, the horizontal shift, is just equal to this right here, pi. Okay, that's how far we had to shift to start our cosine curve. All right, and then finally, the vertical shift. Okay, D represents the vertical shift. So the vertical shift, the formula for that is max minus amp. All right, so the maximum height is 2. And then minus the amplitude we found over here to be 1. And 2 minus 1 is 1. So D is equal to 1. Now, here's something I want to just point out. Okay, if I were to take my eraser, right, and erase all this stuff that I put on the curve here, look at this curve. Look at this curve right here in number 26. Now look up at the top of your paper. Look at the curve in number 25. Isn't it the same exact curve? Okay, they are the same exact curve. They look exactly the same. When I made this handout, I copied and pasted the curve from the top and put it right down here. So basically, any sine curve can be rewritten as a cosine equation. You could write any sine equation as a cosine equation and any cosine equation as a sine equation. Now think about it. Isn't the amplitude from number 26 the same as the amplitude from 25? Isn't the frequency from number 26 the same as the frequency from number 25? And isn't the vertical shift from number 26 the same as the vertical shift from number 25? They're all the same. The only thing that changes when you convert from a sine equation to a cosine equation is the horizontal shift. Okay, in number 25, we didn't have a horizontal shift. In number 26, we did. Okay, we took our sine curve and we took our cosine curve and shifted it over pi units. Okay, if you start at pi, it's a cosine curve. But if we didn't have a horizontal shift, isn't this just a sine curve? Okay, so what I'd like you to write in your notes is this, okay? This is the same exact curve as above. All right, this is really important. This is the same exact curve as above. All right, any sine function can also be rewritten as a cosine function. The amplitude, frequency, and vertical shift will be the same. The only thing that changes is your horizontal shift. So hit pause, make sure you write this. This is very important. Okay, so if you turn to the next page, I'm actually doing that right now. Page 16. So we'll see, you could see that number 27 and 28, look at this. They're the same exact graph. But what they want you to do in 27 is write it as a sine curve. And in number 28, they want you to write it as a cosine curve. All right, this is very similar to what we did on the previous page, so hit pause and try it out on your own. Okay, so I kind of mapped some things out here. Now, let's start with number 27. So when we look at this graph, the amplitude is equal to the max, which here, this maximum value is at a height of 3. Okay, the y value is 3. And then minus the min. The min is at a y value of 1. So 3 minus 1. Okay, the max is 3. And the min is 1. Okay, so 3 minus 1 is 2, and 2 divided by 2 is 1. we know our amplitude is 1. Okay, so the frequency. The frequency is 2 pi over the period. So the period is how long it takes horizontally to complete one cycle. So you just want to say, what is the horizontal length of one complete cycle? Well, it takes pi units, right? Isn't this one complete sine curve? It takes pi units to get there. So in place of period, we're going to replace that with a pi. So this would be 2 pi over pi. So the pi's cancel, and our frequency is 2. Okay, and then the final thing we have to find is, this time they used D. I know in the last example on the previous page they used a C out here, but they're using a D. It doesn't matter what variable they use. They can use an F, they can use a G, they could use whatever they want. But if there's a constant being added or subtracted to the end of the function, that's our vertical shift. All right, so our formula for vertical shift is max minus amp. So we already said the maximum height is a y value of 3. And then minus the amplitude we found to be 1. So 3 minus 1 is 2. Okay, so those are our values in 27. The amplitude is 1. And let's just look at this, okay? I'm going to put a dotted line at the middle height of this graph. Okay, so the amplitude we know is the height from the midline. If this is the midline, are you just going 1 unit up to get to the maximum point? So the amplitude is 1. Frequency we found to be 2. The frequency is the number of complete cycles between 0 and 2 pi. So let's think about this. If we're fitting 1 cycle between 0 and pi, if we were to go to 2 pi, wouldn't we fit another cycle? So we would fit 2 cycles. Okay, and the vertical shift is just how far you had to shift up to get to your midline. So the midline is at 2. Okay? Now, for number 28, if you recall, think about it. If you forget, just think about it. What are the 3 things that stay the same when you convert from a sine equation to a cosine equation? Well, these 3 things right here, the amplitude, the frequency, and the horizontal shift. So in number 28, we can just fill these in with the same values we have up here. Okay, so the amplitude was 1. The frequency is 2, and the vertical shift is also 2, okay? This, and this. Okay, so A, B, and D, these are the same as above. I'll just say same as number 27. Now the C. Okay, let me move this up a little so I can work with this graph here. Okay, the C, right? The vertical shift. Oh, I had these labeled wrong. Okay. All right, let me change that up. So this should say horizontal shift, and this should say vertical shift. And it's actually really easy to remember because it goes alphabetically, right? A, F, H, and V, okay? So sorry about that. I don't even know why I had that like that. But anyway, the only thing that's different is the horizontal shift. So let's find the horizontal shift. Now, since we're talking about a cosine curve, we know a cosine curve looks like this. It starts high, drops down low, and ends off back high. So we want to figure out where is that high point on this graph right here. Well, that high point is right here. This is the beginning of a cosine curve. Okay, so how far did we have to shift horizontally to get there? This is how far we had to shift. Pi over 4 units. So the C would be pi over 4. That would be our horizontal shift.